Okay, for problem number one, it says for what real numbers m, so m is a real number, is the graph. Well, looking at that, looks like a circle. And then they go on and say tangent to the graph of, and that looks like a line. So let me go to the whiteboard and try to visualize what they're asking for, and then I'll try to find out what m is. All right? So again, keep the question handy. This is number one. And again, the question, I have it printed out. For what real number is m? So I'm going to say m is a real number. They give me a circle. I'm going to write this down for you. So the circle is x squared plus y squared minus 4x. Let's see, minus 6y. Here comes the tough part. I got m minus 13. All right, what I'm going to do first is I'm going to try to visualize the circle. I'll get to the question later. But visualizing this thing over here, just like what you did in a basic algebra course, equation of a circle. I'm going to complete the square. Half of minus 4 is minus 2. Square it, you get plus 4. Add 4 to both sides. Half of minus 6 is minus 3. Square it, you get plus 9. So add 9 to both sides. And what do you get? You get x minus, let's see, 2 squared. And then you're going to get plus y minus 3 squared. And this equals what? Well, things just seem to cancel off nicely, right? Because 9 and 4 is 13. And minus 13 minus 13 is 0. Let's just get m. All right? So looking at this thing, I know I got a circle over here. I'll put this down. Yeah, rough picture of it. I just don't know the radius of it, but the center of this thing is going to be 2, 3. And the radius of this thing is just root m. All right? So let me take a look and see what we got. By the way, m here has to be greater than, for it to be a circle. I'm going to say just greater than or equal to 0. And it could be degenerate, just could be a point. I haven't read too far into the problem. So 2, 3, I got this 1, 2, and then up 3. 1, 2, 3. That's where my center is. Then there's a circle. Now there's a series of circles here. I'm not sure what the circle is, by the way, but there's a series of them. If it's degenerate, it would be just that point. And again, if it gets bigger and bigger, you could just imagine, visualize it getting bigger at the center of that thing over there. All right? So I got that. Now the other question is, there's going to be a curve over here. Let me write this one down for it. Not a curve, it's a line. And that line is x plus y is equal to 5 plus the root of 2m. Now here m has got to be greater than or equal to 0, just like before, by the way. All right, this real number. And let's take a look at this. All right, it's the equation of a line y equals, it's going to be minus x plus 5 plus root 2m. Now, by the way, I know this is definitely a line. It's got a slope. Maybe I shouldn't write that down. It's got a slope of minus 1, and the y-intercept is not negative. All right, so I'm starting to realize over here that I got a line, and it's going to be negative, something like this over here. All right, slope of minus 1. Again, visualizing the circle, I guess you could see the circle maybe like this over here, or maybe like this over here. And what I got to do now is I got to work in getting the. Let me read that question. For what real numbers m? Yeah, the tangent line, right, is tangent to the curve. So what I got to do is I got to figure out where this slope is going to be minus 1. So let's write this down now. And I'm going to put this down. X squared plus y squared minus 4x minus 6y equals m minus 13. I'm going to differentiate it, and that's going to be 2x dx dx, 2y dy dx, minus 4 dx dx, minus 6 dy dx, and that equals 0. All right, let's keep going. And what do you get? You get dy dx. That's going to be 2y minus 6. And that's going to be equal to 4 minus 2x. Guys, keep moving. So dy dx equals 4 minus 2x over 2y minus 6. And let me take a look at that. And I'll write this down for you. It's going to be equal to 1. I'm sorry, minus 1. Again, the slope over here is minus 1. All right? Let's write that down. So 4 minus 2x equals 2y minus 2y plus 6. So I'm going to say 2y minus 2x, and I'll take away 4 from both sides. I get 2. I can divide both sides by 2, and I get y minus x equals 1. All right, let's keep moving. So y minus x equals 1. And let's take a look. I think I can figure something else now. All right, let's write this down. And the other equation I had, the other line, was x plus y equals 5 plus the root of 2m. So I'm going to kind of look at these two over here. And I want to just see if I can figure out, yeah, I think I can figure out x and y now. All right, let's take a look at that. And to do that, let's see, just a plug in. I'm going to make a substitution over here. I'm going to say x equals y minus 1. Let's plug that in. So y minus 1 plus y equals 5 plus the square root of 2m. I get 2y. It's going to be 6, and that's root of 2m. Let's see if I did it right. Yeah, I think I did it again. I'm going to divide by 2. So y would equal 3 plus, I'm dividing by 2 by the way, the root of 2m over 2. And you know what we're going to do? We're also going to figure out what x is too. And how am I going to do that? Let's do this. Make another substitution over here. I'll say y equals 1 plus x. Let's plug that in. I think I'll plug it back in over here. So you get x plus 1 plus x equals 5 plus root 2m. You get 2x equals 4 plus root 2m. And x equals 2 plus the root of 2m over 2. All right, so we know what x and y is, all right, for this to occur. And then I'm going to plug it back into that equation. And I'll point out what that equation I'm talking about, the equation of a circle. X minus 2 squared. We already derived this, and I'll point out where this is, by the way. We've already derived this. Where's this going to be? Way up here. We derived it way up here. All right, let's keep moving. And let's see what we got over here. What's the x going to be? Well, this is the x. Plug it in here. Well, that's easy. You just get the root of 2m over 2, quantity squared, plus, let's plug the y in. And this is the y, by the way. We're going to plug it in here. And that looks pretty simple, too. You just get this over here. And again, I think we're pretty close to getting what m is. So what do you get over here? You get 2m squared over 4 plus, I'm sorry, not 2m squared. Sorry about that. 2m over 4 is equal to m. What do you get there? M over 2 plus m over 2 equals m. Well, m is equal to m. Wow. So what does this really tell us over here? Well, I got to think about it again. So I want to point out what I'm thinking about over here. It seems like any m would work. It seems like an identity at this point. So remember, we got this 1, 2, 1, 2, 3. We got a point here. Now, by the way, we also have a line, and the line's coming down with a negative slope, by the way. All right, negative slope. But what I point out is the m has got to be greater than or equal to 0. But I'm going to say, I'm going to exclude the 0 now. And the reason for that, I wouldn't have this is a point, there's no tangent to that. Let's put this over here, but m is greater than 0 now, all right? So we definitely get a circle over here, all right, with the given m. And what's the m going to be? M is greater than 0. And what do we have over here? We'd have a tangent line that would go through that, all right? What's that tangent line going to look like? Well, let's write the tangent line again down. It's going to look like x plus y is equal to 5 plus the root of 2m. Again, m is greater than 0 now. And y would equal minus x, let's see, plus 5 plus the root of 2m. All right? So what do we have over here? We definitely have a negative slope, and we have a y-intercept. Well, let's think about that now. And the y-intercept here is, it's going to be that number there, and that's going to be 5 plus root 2m. So it's going to be up here somewhere, all right? So 5 plus the root of 2m, and it's going to have a line that goes down like this over here. But what I'm starting to realize is that it's going to be an infinite number of tangent lines, all right? The circle gets bigger and bigger, an infinite number, all right? So let me see if I covered that. I'll go back and read it again. For what real numbers m? I gotta think about it a little more carefully, don't I? For what real numbers m? Well, as this circle goes up, let me just think about that. There will be some stopping to that, though. So I know m is greater than 0. As this circle gets bigger and bigger, well, you know what? This thing keeps moving up. That's true. So all I got to do is condition on this over here, m. The only condition I need is m greater than 0, and there'll be an infinite number of tangent lines that do that. Again, the y-intercept keeps moving up as the circle gets bigger and bigger. And we're done. Thank you.